Listen, I get it. You're feeling cooked in AP chemistry already and don't even know where to start. I'm glad you're here watching this video. The goal is just to give you some survival tips for these first few weeks. My name is Corinne, and I embarrass myself on social media to try to help as many students as possible. You can click on any of these links in the video notes just to see some of the things I've worked on in the past. A little bit about me: I have 12 chickens, 3 kids, 2 degrees from UVA, too many hobbies to count, and Michael Fairval was my mentor teacher when I decided to become a teacher. So, yes, chemistry is definitely my thing. I also grew up in Oak Ridge, Tennessee. So, where everyone is pretty much a scientist or an engineer. So, that's a little bit about me, but you're not here to learn about me. You're here to learn about chemistry. So let's get into that. So goal of this is just to give you an overview of the course and the exam. I'll share just some simple tips and tricks, answer some of the questions that have been coming into my DMs, and then review the essential skills that you'll need from Chemistry 1. All right, so exam details. Hopefully this is not new news, but just in case, your exam is going to be split into 2 sections. You have the MCQs, the multiple choice portion, and then the free response questions. Free response are going to be split further into long and short answer questions. You can take them however you want to. Just know that you are supposed to spend about 23 minutes per long answer question, about 9 minutes per short answer question. I will share strategies later on in the year and how to tackle these, but that's kind of the breakdown of the test. You will be taking a hybrid exam this year, just like last year. So that means the MCQs are all going to be electronic. So you'll sit down, you'll take that portion, then you'll come back after a break, you'll take the FRQs. So you'll see the FRQs on your screen, but you'll have a paper booklet to answer all the FRQs. The hope is that you're also going to have a paper periodic table and equation sheet. There was a lot of drama last year. I don't know if you heard about it, but all students were actually allowed to take a retake of AP Chem just because this was not provided on paper. So the hope is that you will get paper copies of those, but we'll talk more about that in a second. So let's look at the course breakdown. This is just the CED from College Board, shows you exactly what you're going to cover this year. Notice the emphasis on units 3 and 8. So unit 3, it's not just IMF, intermolecular forces. You also have gases, gas laws, all kinds of things in that unit. That is why it's weighted so heavily. Unfortunately, what students and many teachers believe is the most difficult unit is the second one, that second highest weight, right? Unit 8. But you will get to that point. We're not there yet. Thankfully, no one's going to be studying Unit 8, hopefully until the spring when you have a lot more chemistry under your belt. So looking at FRQs, this is what a typical FRQ looks like. This is from 2021. It's actually on photoelectron spectroscopy, something you may have already learned in class. It's topic 1.6. So a lot of these FRQs, you're going to have lab data. You're going to have lots of different portions. This even includes energy calculations in there. What you need to know, though, is with these FRQs, don't be intimidated by the fact that you have parts A through F. Instead, always focus on answering what you know, and the basics of chemistry will go a long way, or at least they have the last couple years. Again, we'll get back into that in just a little bit. So these are the results from 2025. So even though there were a bunch of questions on there that looked completely different from anything we had seen, students still did well on the exam. So 78% of the students that took the test, we don't have the numbers yet for how many students, but I would guess it's probably around 100, somewhere between 140,000, 155,000. 78% of those students passed the test with a 3 or above. Okay, so know that going into the test, the hard part of this course is probably not the AP exam, it's probably the actual class. So let's give you some tips and tricks for that. And that actually goes into my next point. Even if you are not taking the exam, this is such a valuable experience to endure, really. Even if it's the first time you're really struggling through a course, I know that feels really intimidating and overwhelming right now, but I promise you're going to grow as a student. And by the end of this course, everything else is going to feel easier. So hang in there, keep that chin up, and know that it does get better. All right, so just some simple tips and tricks. Don't underestimate the power of these really simple things and be consistent with these. So my first tip is always take your own notes. Just screenshotting your friend's notes does nothing for you. So I want you actually putting the pen to paper, taking your own notes, and then revisiting them within a day of class. So whether you're on a block schedule or you have class daily, I want you going through and looking at those notes. If you have the time, rewrite them. but spend enough time looking at them. Don't look at them as you fall asleep on them. Actually look through it, make sure the problems make sense so that you can ask questions. My next tip is to stay organized. So with all of these notes, this is a cumulative course. Therefore, you're going to need to refer back to all of these initial notes, problem sets, labs. Find a way, a system to keep everything organized. All right, you also want to use the tools that you're going to have access to on test day. So that means use your calculator, get in the habit of bringing it with you to class. Also use College Board's periodic table. You'll notice the names of the formula, the chemicals, the names of the elements are not listed, unfortunately. So yes, you need to know that W is tungsten and things like that. If you need help with some of those symbols that don't match up, I do have free flashcards already built out for you, but also the equation sheet. You want to know exactly where to find each equation, each constant, so that you're not wasting time on test day. So I want you also to complete any and all practice that you receive, even if it's ungraded. I can't emphasize enough how important it is to get active practice in this course. There are so many different ways to ask these questions. So the more questions that you have been exposed to, the more ready, the more prepared you're going to be for whatever is thrown your way on test day. I want you also asking questions. Don't be intimidated by this course. If you have questions, chances are 5 other students in your class have the exact same question. If you don't ask questions, your teacher's just going to be there yapping away, thinking that you guys all get it. You don't. Ask questions. If you are intimidated by that, send emails. And if you don't feel comfortable asking your own teacher these questions, ask me these questions. This is what I do for fun. So send me DMs, send me emails. My email is chemwithcorinne@gmail.com. I promise I want to help you. All right, next up, I want you also forming a study group, because when you can't access your teacher or other help, you want to find students in class that you can bounce questions off of. Also, it is really valuable in this class to have someone to commiserate with. It is a difficult class. There is no denying it. So having a buddy, someone who gets it, makes a big difference, because your friend taking APES is just not going to get it, right? It's not the same. All right. I also want you leaning into those outside resources. Even if you have no idea what PES is, you're like, what are you talking about? You need to watch a video on photoelectron spectroscopy. There are so many free resources out there for you. That's also the truth when it comes to all the practice available to you. And speaking of free resources, here are some of my favorites. Khan Academy has an AP chemistry course that's already built out. So with videos, exercises, and then articles. Articles are their lessons that kind of talk you through the topics with questions built in. Really valuable. And if you are sitting there and you're like, whoa, I don't remember anything from Chem 1, they have a Chem 1 course also built out. So if you need to go and run through stoichiometry, you can, right? It's a great resource for you, and it's all entirely free. When it comes to YouTube videos, Jeremy Krug is the GOAT of AP Chemistry right now. He has produced so many really great videos in the last couple of years. Michael Fairbaugh was my mentor teacher, so of course I'm going to push his resources. You're probably using his packets in your class. His resources are really valuable and just really straightforward. And then I have flashcards, problem sets, and short form content out there. I am trying to build more videos like this on my YouTube channel. And every time I build a video, I try to also attach practice problems with it. I think it's really easy to find lots of practice out there, but you can't exactly just type into ChatGPT, give me some practice with mass spec. ChatGPT is not there yet, right? Like it is not at the level of AP Chem. So I like trying to provide just AP Chem practice that's going to align well with what you're going to see on your test. All right, so here are all of my tips and tricks. Again, if you have questions about these, please drop them in the chat. I think this is all pretty straightforward. Yes, these seem like really small things to do, but being consistent with these small things makes a big difference when it comes to May 5th. So yes, your exam is at 8 a.m. on May 5th, 242 days away. I know that seems like a long way, but it is going to fly by. So get consistent with these, start taking your own notes, keep things organized, use all the chances you can to really build out the basics, because actually in the last couple of years, the basics would be enough to get you at least a 3 on this exam. So don't knock, just really feeling solid with some of those Chem Level 1 concepts. And speaking of Chem level concepts, these are the essential skills you really are expected to walk into AP Chemistry knowing. Every situation is going to be a little bit different. Maybe you are taking AP Chemistry as your initial chemistry course, and that's what everyone does at your school. But for the most part, this is what students are sweating right now, right? Like stoichiometry, everything. Stoichiometry was the hardest thing you learned in Chem 1, and all of a sudden you're expected to know it from the moment you walk into this course. So let's talk about some of these basics. So when it comes to bonding and nomenclature, these are all the things that you want to feel really confident with. I do recommend memorizing the polyatomic ions. Technically, you don't have to memorize them, but I feel like it saves you time, and anything that saves you time is money in this course. So I recommend spending 10-15 minutes memorizing those polyatomic ions. So let's just do some practice with nomenclature. I want you to pause the video here and try to determine the name of these 3 compounds. All right, so that first thing you need to do is you need to look at each of these and decide whether each is ionic or covalent. So if it is ionic, we're looking for typically a metal and a non-metal. Not the case in the first one. That is the exception with ammonium. Versus covalent, we're going to see 2 or more non-metals or 2 or more things from the right side of the periodic table. So the first one is ionic. We're going to transfer an electron from ammonium to sulfate. Actually, we have 2 ammonium ions. We're going to transfer 2 of those over to sulfate. So that is going to be ammonium sulfate versus P4O10. Like I said, that is covalent. That's going to be tetraphosphorus decaoxide. And then finally, we have VCl5. So you need to look, you find vanadium, it's a transition metal. Got to indicate the charge with Roman numerals. So we're going to work backwards. You're going to look at the anion, the negative portion of that formula. We have 5 chloride ions. Chlorine is in the halogen column. That means it has a charge of -1 because it has 7 valence electrons, wants 1 more. We have 5 of those. Our net negative charge is -5. That means that 1 vanadium ion has to carry a charge of +5. If you would like more with this, you can check out this video. It's linked in the video notes, so you can have access to that as well. So that's just like I think it's like 12 minutes long, just going through nomenclature, so you can feel really solid with that topic. All right, moving on. So this really comes in Unit 2, but understanding molecular geometry, being able to predict polarity, and identifying intermolecular forces, those 3 skills are so important for this course. So let's just do a practice again. Go ahead and pause the video here and try to identify the intermolecular forces the compound on the left is going to experience. All right, so when it comes to intermolecular forces, right away, you're going to say this experiences LDF, London dispersion forces, because everything experiences LDF. Then you're going to look at each of these bonds. You're going to figure out which are polar versus non-polar bonds. So carbon to carbon, 2 of the exact same element, they're going to share electrons equally. That is a non-polar bond. Carbon to hydrogen is also a non-polar bond. I wish I could have that tattooed. That is so important and such a big misconception. So the CH bond is always nonpolar, but the carbon to oxygen bond is polar. So what that means is we're going to have a partial negative developing at the more electronegative atom. It's going to be the oxygen. And that leaves the carbon with a partial positive. So that just means the electrons are going to be distributed more towards that oxygen atom. So that's why we have that partial positive versus partial negative. And that is why we have a dipole-dipole interaction also occurring. So between these different molecules, if another molecule, this is acetone, the compound in nail polish remover, if another one of those comes in, right, that negatively charged oxygen is going to interact with the positively charged carbon somewhere else. We don't have hydrogen bonding with this because we do not have a polar hydrogen atom. If this were dissolved in water, however, we would have hydrogen bonding. So hydrogen bonding occurs when you have a polar hydrogen interacting with a very electronegative atom, either oxygen, nitrogen, or fluorine. All right, if you would like some more on this is just more on the different types of IMF. Like I said, you are going to spend a whole lot more time on IMF than you want to this year. Big takeaway with IMF, the stronger the intermolecular forces, the harder it's going to be to disrupt those. So because of that, that's going to lead to a higher boiling or melting point, things like that. So being able to identify the IMF and then justify what's going on in terms of physical properties, really valuable skill in this course. All right, moving on. Periodic trends. This definitely comes into play in Unit 1. So I want you not only to be able to tell me, oh, it's because phosphorus is to the left of chlorine, blah, 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 blah. Oh, it's because the arrows. No, you can use the arrows to memorize the trends, but you need to be able to describe what is happening, what is causing that increase in ionization energy as we move from left to right across a period, right? So when it comes to atomic radius, everything kind of ties back into that. So the atomic radius is going to increase with increasing electron cloud. So as I move down a group, right, my electron cloud increases because I'm adding energy levels. Makes sense. So that's why the atomic radius gets larger as you move down a column or a group. As I move from left to right across the rows or periods, though, the atomic radius actually shrinks a little bit. And this is a big misconception. Why does this happen, right? It's as we move across across a period, we are adding protons to the nucleus. As we add protons, we increase the magnitude of positive charge. Oh, opposites attract. As there's a greater positive charge in the nucleus, the electrons are attracted inward towards that nucleus. Okay, so as I move from left to right, the atomic radius actually shrinks. The official term for this is the effective nuclear charge. So as I add more positively charged protons to the nucleus, that increases the effective nuclear charge, leading to a stronger attractive force for the electrons. We call that Coulombic attraction. So the radius actually shrinks slightly. And then when we think about ionization energy, right, the amount of energy required to remove an electron, that is the opposite of atomic radius, because the smaller the radius, the closer the electrons, the stronger that Coulombic attraction. Therefore, the more energy that's required to pluck one of those away, right, to pull one of those electrons out. Let's do some practice with this. So take a look at this MCQ. This is an old AP question. I want you to predict the likely identity of that third period element. So see where that question mark is. Pause the video here and give it your best shot. All right, so what you are looking for is a big jump in ionization energies. So when you see that big jump, that indicates we're moving from valence or outer shell electrons into those inner or core electrons, because it's going to take a lot more energy, right, to remove an electron that's closer to all of that positive charge in the nucleus. So looking at this, I'm going to see that there's a massive jump between IE 3 and 4, indicating that this element has 3 valence electrons. So I'm going to go to period 3 or row 3. I'm going to identify this as aluminum. You can also use the same logic to identify that second one as magnesium. So this is a pretty straightforward, but if you don't know ionization energy, you don't know what's going on, it's really intimidating, right? So just knowing the basics of what's going on makes a big difference. All right, and next up, this has been the most highly requested topic, stoichiometry. And I think it's really intimidating in AP because this was the hardest thing you probably learned in Chem 1. You walk into AP and boom, you're expected to write chemical equations, predict those theoretical yields, identify limiting reactants. Oh wait, that's just a multiple choice question, right? So you're doing all of this immediately. But if you just focus on the basics, you will get there. And before you know it, stoichiometry is going to be the easiest thing you will have learned this year. So I've linked just some videos. This is just a stoichiometry map kind of to show you. Your goal is always to convert from whatever you're given into moles. Because if you are going to use stoichiometry, right, you are going to compare two things on a mole-to-mole basis using those mole ratios from the balanced equation. From there, you can then convert your answer into whatever the question is asking. Let's do a practice problem with this. So let's do fake blood. So fake blood is made by mixing KSCN with FeCl3. We're given the reaction. Thankfully, in AP Chem, you're often given the chemical equation, which is great. It's not always balanced, though, so be careful. So our question is, how much fake blood will be produced if 5 grams of each reactant is used? All right, so what do we need to do first? We need to balance this equation. Quick trick with balancing, follow those polyatomic ions. Thiocyanate, the SCN. You'll notice it doesn't split. Oh, where did my potassium go in this? I lost my K. So I should have KSCN as that initial reactant. But anyway, we're going to see that we have 3 of those on the product side. We're going to need 3 on the reactant side as well. Once I do that, that means I have 3 atoms of potassium. I need a 3 in front of KCl. boom, everything is balanced. All right, so step 1, balance your equation. You're going to need the balanced equation to use those mole ratios. Step 2, organize what you know versus what you are looking for. So I like to put all of my values directly underneath that equation just to try to keep track. So put what you know, also put in what you're looking for and the units associated with that. I think it's really easy to get lost in these types of problems. So always know exactly where you need to land at the end of these calculations. All right, so step 3, we got to figure out which one of these is our limiting reactant, because that's going to determine how much of our product we actually make. So what we're going to do is we're going to divide by the molar mass of each, because your first step, we can't compare things unless they are compared in terms of moles. So we want to convert from grams into moles. We divide by the molar mass. Now we have our moles of each reactant. We can then use those to use the mole ratios to convert from moles of our reactants into moles of our products. So for example, KSCN has a 3-to-1 ratio. So we end up dividing by 3. We find out that we will produce 0.0172 moles of that fake blood. The FeCl3, it's a 1-to-1 ratio. That's a bigger number. Again, that means that is excess because we are limited by the KSCN, the potassium thiocyanate. All right, and next up, we got to calculate our yield. So now take your answer in moles, multiply by the molar mass of that product, and you will have your final theoretical yield. There's one more step, right? You got to round for sig figs. So I will preface this by saying there's only one point on the entire exam that is dedicated to sig figs, but I want you to get into the habit of just thinking through sig figs, because I can't guarantee that your teacher feels the same way as College Board does about this. So you want to get in the habit of probably like 3 sig figs for most answers, but what you do is you look back at the initial values given in the problem, your least precise value, so the one that has the fewest amount of sig figs, will determine the number of sig figs in your answer. It's always okay to write the full answer that you see on your calculator screen. No harm in that. But then make sure you are rounding and adjusting to match the precision of your initial measurement. So in this case, this would be a 3.96 gram yield. If you haven't seen this reaction, I will definitely post it on my channel at some point. It is a fun one. I will say we typically you're going to use solutions with this. So you'll combine 2 solutions. You'll have a clear solution. You combine the other one and then boom, bright red solution. It's really fun. It's often used in theater and movies and things like that. All right, other requests I have received in my DMs, empirical molecular formulas. The trick here is to remember this rhyme: percent to mass, mass to mole, divide by small, multiply to a whole. It is a process, but you can follow this process with any problem and you will get to the right answer. I'm also going to post a new tutorial on combustion analysis. I know that can be a little bit intimidating because you're looking at mass of CO2 and H2O instead of just percentages of those elements, but you're just going to use stoichiometry. If you have 8.27 grams of CO2 produced, convert that into moles. Then you can convert moles of CO2 into moles of carbon and still follow the same process. So I have this old tutorial linked, but you can also keep an eye out for next week for another tutorial on that. All right, another big request was just electron configuration. The best way to master this is just to practice. Print out a periodic table, do some coloring, take a minute to breathe, block out where your S, your P, and your D are, and then just practice. Remember that the D's and the F's are lower than the rows that they are in. And there's always the trick. You can always just add up your exponents. So, for example, let's say phosphorus, element 15. You have written an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p3. And you're like, is that right? Add up your exponents. When you add up all of the exponents, you'll have an answer of 15, which matches with the 15 electrons that you need to show. All right, let's see. So if you'd like more practice with some of these just essentials, you can check out my Chem 2 Bootcamp course. If you use the code LIVE through Friday, you will get 50% off that course. So 5 modules, just short, quick, to the point, things that you will need this year so that you feel really ready for the rigor of this course. And we're almost through it. If you are feeling overwhelmed, know that everyone is, whether they're admitting it or not. This is a tough course, but I promise you are ready for it. You are going to learn so much chemistry. You're going to grow so much as a student this year, and I'm excited to support you on this journey. So thanks for watching tonight. I hope this has been helpful. Let me know if you have any questions, and please help me continue to share these accounts. My goal is just to help as many students as I can. I miss being in the classroom, and I'm here to help you all out. So best of luck this year, and